Literal equations. Literal equations are quite exactly what the name says. Equations that have very few, if any, numbers in them and are composed predominantly of variables that stand for different things. Usually we have to rearrange them to get them to make sense. The first one we'll look at is d equals rt. Some of you will recognize that as distance equals rate times time. And then we can move them and manipulate them however we need to. So let's say we have a problem that gives us both distance and rate, but we don't know time. Now we could plug it in and solve backwards and that would be fine. But if we wanted to, we could rearrange the pieces here just so that we see time as its own thing and by itself and everything else on the other side. So the first thing that I always like to do when I'm looking at literal equations is make a list of what's happening to the variable that I'm looking for. So I'm looking for t. And as I'm finding t, what's happening to t? And so my list is that it's being multiplied by r. And really that's the end of my list. And so I go down my list to make it, and then when I find it, I work my way back up my list. And so I'm going to undo on this side. So I'm really going to divide by r. So when dividing by r, it cancels there and cancels and comes over. I can now rewrite the equation as d over r is equal to t. And so all I've done is essentially used a mathematical concept of multiplication and division working inversely to separate that r and the t and get me t equals whatever's remaining. So go ahead and try this next one. Let's look at area equals length times width, and I want you to solve for length. So we have the area of a rectangle, and I want you to solve for L. So go ahead and pause it, see if you can work it out, make your list, and then do the inverse operations and solve for L. Hopefully you got a chance to pause it and take a look. I'm going to go ahead and make my list. Even though it's only one thing, it's still a good habit to have. I know that L is being multiplied by W, and as I made my list down, now I work my way back to find L. So I'm recognizing that I need to do the inverse and divide by W. So I'm going to divide by W, divide by W. I'm going to end up with A over W is equal to L. Alright, so let's try another one. This one will be a little bit more involved, have another step. So let's look at the kinetic energy formula, which would be K is equal to 1/2 mv squared. Really wasn't a good V. That's better. So kinetic energy. So this is a physics problem, but don't get intimidated by what's going on. We're simply going to rearrange the pieces as we need to find what we're looking for. Using inverse operations, it's the same as if there were numbers, and so we do see a little bit of some number in here with 1/2 and squared, but for the most part we have a bunch of variables that are unknown. We're just going to rearrange the problem and see what we get. I want you to solve for m. And so pause the video, see if you can work this out, make your list, work it backwards, and see if you can get m by itself. So the first thing on your list, or actually could be either one, it would be multiplied by 1/2, and then also it's multiplied by v squared. And remember that squared on there, that goes with the v. And so that's my list, that's what's happening to m. So I've made it down, and now I'm going to work it in reverse. And so the first thing I'm going to undo is dividing by v squared. So I can do that. Divide by v squared. Those cancel. Divide by v squared. So I have k over v squared is equal to 1/2 m. And so now I'm at that second step, coming back up my list, and now I see I'm multiplying by 1/2. And so I can either divide by 1/2, but really what we're doing there is multiplying by 2. I suppose you could write or dividing by 1/2 technicalities, it's the same thing. So I'm going to come back to my problem, and I'm going to go, all right, I need to multiply by 2 on both sides. So now I get 2k over v squared is equal to m, because this cancels there, and that's what I end up with. So 2k over v squared is equal to m. Let's try another one, this time with 2 different types of. So let's look at P is equal to 2L plus 2W. A lot of you will recognize that as the perimeter of a rectangle or a square. Or rectangle, I guess it would be 4S, would be fine for a square. But P equals 2L plus 2W, and I want to solve for W. And so this time, pay attention to different things that are happening. Start with what's happening directly to W, and then kind of work your way out. So we're going to look at it and go, okay, the first thing that's happening is it's being multiplied by 2. Then you are seeing that it's being added to 2L. So I can write all that in one step. So it's being increased. Get my pen back. Increased by 2L. And so that's my list. That's everything that's happening to W. And so I've made my list down. Let me work it backwards. So as I work it backwards, I need to subtract 2L. And so I'm going to go ahead and bring 2L off of this side, subtract it from P. Well, those aren't like terms, so I just get P minus 2L. And now I need to divide by 2. So dividing by 2 will look a little different because one of these has a 2 coefficient on it, or a coefficient of 2 on it. So divide by 2, so I have equals 2W, so divide by 2, and so I notice here that those 2's will cancel out, but it does still have to stay on that P. So I get P over 2 minus L is equal to W. Let's try a couple more, and I'll keep kind of amping up the intent. So let's look at area is equal to 1/2 of base 1 plus base 2 times h. So this is a trapezoid. I don't expect you to know that. It's just something that we're going to work with. This time, I want you to see that B1 and B2 are actually different variables. That's why we use that subscript of 1 and 2. That helps us understand which one's which. One's different. They're different bases. And so I'm going to look at it, and I'm going to say I want to solve for B2. So we got to kind of make quite a list here. Now remember, we're working inside out, and we're going to work off the parentheses, and we have to work along those lines. So pause it, try it, see what you think, and then come back and check it. All right, I see the first thing that's happening to B2 when I look at this is it's inside those parentheses, and so it's being increased by B1, added to B1. The next thing would be a multiplication by 1/2. And then there's also a multiplication by h. And really that multiplication in 1/2 doesn't matter. Sometimes you'll see them written together. It'll be 1/2 h times B1 plus B2. And so you can kind of loop them together. That's fine. We'll separate them just for our purposes. But either way will work. So we made our list down. Now let's undo it and bring it back. Solving for B2. First thing I'm going to do, all right, I see it, divide by h. So everything over here, divide by h, divide by h. Hope I have enough room. A over h is equal to 1/2 B1 plus B2. Still working back up my list, so the h's are done. Now let's look at multiplying by 1/2. Okay, it's the same as dividing by 2, so again, the technicality, I'm just going to say multiply by 2. That inverts that. Multiply by 2 over 1. Multiply by 2 over 1, so I get 2a over h is equal to b1 plus b2, and I don't need parentheses anymore, there's nothing left. And so my last step is to, instead of add b1, I'm going to inverse operation there and subtract b1. So my final answer, and I'm going to kind of work it this way, is 2a over h minus b1 equals b2. All right, last one, we're going to take a look back at physics. We're going to look at velocity. So we're going to have velocity is equal to the speed of, or velocity at 0, plus acceleration times time. Again, you don't have to know these. These are just something fun. Because we can deal with physics, we might as well. I'm going to take that bar off. It does mean velocity. That's what the bar over top means. Otherwise, we kind of assume it means volume. So I want you to solve for A. So pause video, try it, make your list, and then see if you can get this one. First thing that's happening to A is it's being multiplied by T. So I see A and T together. Whoop. A and T together. Now I got to go to the next thing. The next thing is it is being increased by v sub 0, or the initial velocity. And that's really all I have going on. So I'm going to say, all right, I made my list. Now let's work it backwards and see what's going on here. So I'm going to subtract v sub 0, move it over. So I have v minus v sub 0. Now remember, just like that b1 and b2, these two are different things. V and v sub 0 are two different, so we can't combine those. Be careful there, even with those subscripts, that matters. So I'm going to come back and say, okay, now I have v minus v sub 0 is equal to a times t. So let me keep going up my list here. And I see that I'm multiplying by t. So to undo that, I'm going to divide by t, divide by t, divide by t. So I have v minus v sub 0 over t is equal to a. And there's a lot of different ways we can get acceleration, but that's a pretty good one as well. Hopefully this helps. Hopefully you have a better understanding of literal equations. All you're doing is applying the mathematical principles that's happening between the letters and saying, okay, I know that there would be a number in one of these or both of these, and I can manipulate them however I need to, as long as I follow inverse operations and work them appropriately. I can move the equation around however I want. They're just puzzle pieces. Slide them how you need to using the operations.